Assalamu alaikum. The topic of today's video is normalization of wave function. Well, you have heard about wave function. The wave function was used in Schrodinger wave equation, and we have learned about the wave function, about its physical significance and Born interpretation in our previous videos. So, the topic of today's video is going to be the normalization of wave function. As you know, according to the Born interpretation, the probability of finding an electron or a particle is given by psi squared dx dy dz is equal to psi squared d tau, where d tau is the volume element equal to dx dy dz. So, the probability of finding an electron is equal to this. If we sum up the probabilities of all the position where an electron or a particle can be found, then it should be equal to 1. As you know that if there is a particle in a box, okay, so this particle can be found here, there or there. It can be found within the boundary limits of this box. So if my particle is found within the particle limit, within the boundary limit of this box, so if I sum up the probabilities of every place, then it should be equal to 1. Okay, because 1 means the particle is present within the box, not outside the box. So what is meant by normalization? Normalizing means to multiply the wave function. Normalizing means just to multiply the wave function. We have to multiply the wave function psi by a constant such that the sum of all the probabilities of finding the particle become equal to 1. Normally the wave function is not normalized. To normalize, we have to multiply the wave function in such a way, we have to multiply the wave function with a constant in such a way that the probabilities, that the sum of all the probabilities become equal to 1. So as you can see that the sum of all the probabilities should be equal to 1. So if I take the equation as minus infinity to positive infinity psi star dx dy dz equal to 1. So this is the equation that shows that from minus infinity to positive infinity, the probability of finding the particle is equal to 1. Okay, so sometimes the answer of this equation does not become equal to 1. To make the answer of this equation become equal to 1, we have to normalize this part of the equation. We have to normalize the wave functions here. We have to normalize them in order to get the answer equal to 1. So how can we normalize it? First of all, take an example. A particle is present from minus infinity to positive infinity, and now I am putting a constant with psi. If I take psi is equal to n psi, here n is a constant that is being multiplied by psi in order to get the answer 1. So this n, so this psi changes into n psi, and this psi star will also change into n psi star when dx dy and dz will be equal to 1. So I have just multiplied this psi with n psi. I have to multiply this, I have to normalize the wave function in order to get the answer 1. Sometimes, as I have told you before, sometimes the left hand side of the equation does not become equal to 1. So to make the left hand side of the equation become equal to 1, we have to multiply this psi with a number, with a constant n, in order to get the answer equal to 1. I have just plugged in the value of n psi here and here in the equation, and the equation becomes just like this. So n and n are constant, they will come out and become n square minus infinity to positive infinity psi star dx dy dz. I can take it equal to d tau, and this become equals to 1. So I'm gonna find the value of this constant. So I want to divide this equation, this part of the equation will divide on the right hand side. So this one will become equal to n square 1 divided by this part of equation will go in the denominator of the right hand side. So it will become equal to minus infinity positive infinity psi star d tau. So I want to find the value of this constant n, so I have to take the under root on both sides. So on taking the under root on both sides, the equation becomes n is equal to under root 1 over minus infinity, positive infinity, psi star d tau. Okay, so this is the constant, value of the constant. So to explain this further, let us take an example of a function that is not normalized and normalize it. This is the question: perform normalization of wave function on psi is equal to x square. So we are given the value psi is equal to x square, and the interval is given from 0 to x to k, and calculate the normalization constant. Okay, so first of all, take our previous equation. The previous equation shows that from 0 to k, the psi and psi star d of x. Okay, I'm gonna find the value of this equation. If it becomes equal to 1, then I can say that no normalization is needed. If it does not become equal to 1, then this equation has to be normalized, then the wave function has to be normalized. If the answer of this equation become equal to 1, then I would not have to normalize this wave function. If it does not become equal to 1, then I will have to normalize it. So putting on the value, plugging in the values from 0 to k, psi is equal to x squared and psi star is also x squared, d of x. X square and x square will become equal to x4 dx. First of all, you need to understand the basic rule of integration. If I have integration of a value x of n, x raised to power n, okay, if I am going to integrate a value in which x is raised to power n, d of x, then the integration of this will come out to be just like this. Okay, the integration of this will come out to be n plus 1 divided by n plus 1. I will just have to add plus 1 in the power and divide the number by the same. Okay, so if I have x raised to power n, in place of x raised to power n, I have x raised to power 2 d of x. So what will be the integration of this? This will have an integration equal to x raised to power, since I had n plus 1, okay, so this will become equal to 2 plus 1, and I will divide it by 2 plus 1, and this will become equal to x3 divided by 3. Okay, the next thing is, if I have and I'm going to take another example. If I have x2 and a, okay, since we do not take integration of a constant, the constant comes out of the integration just like this, and we have to take the integration of x squared d of x. Okay, so integration of x squared, as you know, is equal to x3 divided by 3, and this a comes similarly in the final equation. Okay, this is how we take the integration with a which has a constant value multiplied by it. So the next thing, if we are given a range, so what will we do? If we are given a range, like if I am given a range from 0 to 1, and I have been given x2 dx. So what will I do? First of all, I will take the integration of x2, that will come out to be x3 divided by 3. Okay, the next thing, I will put a bracket and I will write 0 to 1 as my limits here. Okay, now I will apply the upper limit here. Now before applying the upper limit, I will have to place 1 in place of x. I have to plug in the value of 1 in x. Okay, first of all, I will use the upper limit. It will become equal to 1 cube divided by 3. The next thing, I will write a minus, and then I will write 0 here in place of x. 0 cube divided by 3. Okay, since this part of equation becomes equal to 0, so my answer becomes equal to 1 by 3. So this is the method of solving an integration with a limit, and this is a general method of solving solving x with power n, and this is an example, and this is also an example in which I have a constant value, say a. Okay, so going back to our question, I have to take the integration of x4. The integration of x4 will come out to be x5 divided by 5, and here is the range from 0 to k. Now if I put on the value, so this equation will become equal to first of all, I put the upper value k here, so x will become k 5 divided by 5. Now I will have to minus the second part of equation. Now 0 raised to power 5 divided by 5. Okay, I have put the upper boundary limit, I have to put the lower boundary limit. So as you know that something divided by 0 is also 0. So my answer becomes equal to k5 divided by 5. Since this answer that I have just derived, this answer, it is not equal to 1. So I can say that the answer of this equation is not equal to 1. So I have to normalize this equation in order to get the answer equal to 1. So to normalize, I have just to consider this equation again. Now, instead of taking psi and psi star, I would take n psi and n psi star in order to find the value of n in order to normalize the equation. Okay, so from 0 to k, that will be equal to n psi and n psi star d of x. Okay, so this is the value that I am going to find. So moving on, n and n are constant, so they will come out like n square 0 to k. I will put down the psi and psi star dx, and now I will going to put the, so now I am going to put the value of psi and psi star like x square and x square dx, and the x square become equals to x4. So moving on, 0 to k, and x square becomes equal to x4 dx. Now if I take the integration of this part, then it will become equal to x5 divided by 5, and here is my boundary condition from 0 to k. So the next thing that I'm going to do is, you know that the answer of this boundary condition, answer of this boundary condition is equal to k5 over 5. So this will become equal to k5 divided by 5, and on putting on the upper limit, the upper limit was k here, so I have put x, also I have put k in place of x. So the next limit, lower limit is 0 raised to power 5 divided by 5. This part of equation becomes equal to 0, so n square multiplied by k5 divided by 5. So as you know that this equation is normalized. Okay, so this equation will be equal to 1. So I am taking n square k5 by 5 is equal to 1. This part of equation will go and divide here. So this equation, this part will become, first of all I am writing again the same part, k5 divided by 5 is equal to 1. 5 will go there, k5 will go in the denominator. So n square is equal to 5 divided by k5. So in order to neutralize this square, I have to take under root on both sides. Taking under root on both sides, under root square cuts down, n is equal to under root 5 divided by k5. So this is the value of norm n that should be multiplied with the wave function in order to normalize the equation. So my previous wave function was psi, that I had taken equal to n psi. Every psi I had taken into I have taken it equal to n psi. So this n here is under root 5 divided by k5, and the wave function and the value of wave function is x squared. So this is my normalized wave function. Okay, so this is my normalized wave function. If I use this wave function here and here, okay, if I use this wave function here and here, then the answer will be equal to 1. So this is the normalization of wave function, that you have to multiply the equation, you have to multiply the psi with such a constant that the answer should be equal to 1, because our answer wasn't equal to 1 previously, but after finding the value of n, okay, if I put this value of n here and here, this answer will become equal to 1, and on my equation, so I can say that here my wave function is normalized. This is my normalized wave function. So taking another example, so moving on towards the next example. In this example, I have to calculate the normalization constant n1 and n2 for question number 1 and question number 2. In question number 1, I have been given the value of psi1 equal to this. In question number 2, I have been given the value of psi2 equal to this. Okay, so first of all, I will use this value of psi in question number 1 to find the normalization constant n over the range of this. So using the formula of normalization, the formula of normalization says that if I multiply psi with its psi complex in d of x over the given range from minus a to plus a, my answer should be equal to 1. So I am going to plug the value of psi 1 here and here. So on plugging in the value, I get from minus a to plus a. Psi 1 has a value n1 a square minus x square, and psi 1 star has a value of similar value n1 a square minus x square. Okay, d of x minus a to plus a, n1 and n1 multiplying, this become n1 square. Since n1 is a constant, so it will go out of the integration. This and this here forms a square minus x square as a whole square and d of x. So here the formula of a minus b as a whole square will be applied, writing the same n1 square minus a to plus a. On applying the formula of a minus b as a whole square, my answer comes out to be equal to a4 plus x4 minus 2 a square x square d of x. Okay, so the next thing that I'm going to do is to apply the integration here. On applying the integration, the answer comes out to be equal to, since a4, okay, since a4 is a constant, the integration would not be applied on a4. Okay, the integration will be applied on 1 that is being multiplied by a. This a has a 1 being multiplied by it, so the integration will be applied on this one. How the integration will be applied on this one? Because as you can see that I can write x raised to power that I can write 1 as x raised to power 0. Okay, if I have the integration of 1 dx, then I can write 1 as x raised to power 0 d of x. So on writing x raised to power 0, the integration of this part will come out to be equal to x 0 plus 1 divided by 0 plus 1. Okay, so this part will become equal to x raised to power 1 divided by 1, which is equal to x. Okay, so which formula I have used here? The formula I have used here is, if I have been given the value of x raised to power n in integration, then the formula is used is just like this. The formula that I've used is this. Okay, so on using this formula here, I'm getting the value of integration of 1 equal to x. So in this way, x will come here plus the integration of x4 using the same formula will become equal to x5 divided by 5 minus 2 a square x3 divided by 3. Okay, this d of x is consumed by integration. So the next thing, I have minus a to plus a as my range, minus a to plus a. Okay, here I have n1 square. Okay, now I will first of all plug in the upper range of a in place of x. On plugging in the upper range, I get a4 x. In place of x, I will write a plus a5 divided by 5 minus 2 a square a3 divided by 3. And now I will plug in the value of minus a in here. So what I have done here is just plugged in the value of minus a in place of every x. Okay, in place of x I have plugged in minus a, in place of this x I have also plugged in minus a, and in place of this x I have also plugged in minus a again. Okay, so the next thing is, on multiplying a4 by a, I get a5. On multiplying this is similar, a5 by 5. On multiplying a square by a3, I get 2a5 divided by 3. And similarly, on multiplying a4 with minus a, I get minus a5. And on multiplying plus minus, it becomes equal to minus and a5 divided by 5. And minus minus becomes equal to plus and 2a5 divided by 3. So this is what my equation becomes after opening the brackets. Now on multiplying the minus sign, I get n1 square a5 plus a5 divided by 5 minus 2a5 divided by 3 minus minus plus a5 minus minus plus a5 by 5 and minus plus minus 2a5 by 3. Okay, so a5 and a5, what will they become? They will become equal to 2a5. And similarly, a5 by 5 and a5 by 5 become equal to 2a5 by 5, and minus 2a5 by 3 and minus 2a5 by 3 becomes equal to minus 4a5 by 3. Okay, so as you know that we are normalizing, as you know that on using the value of n, this is the normalized equation, so this should be equal to 1. Okay, this equation should be equal to 1. Since we have to find the value of n, this equation should be equal to 1. Okay, the next thing, I am going to take a5 as common. On taking a5 as common, the rest of the equation become 2 plus 2 by 5 minus 4 by 3, okay, equals to 1. So this part of equation here becomes equal to, so the answer will be equal to, on taking the LCM of this part, the answer will be equal to 16 by 15, 1. The 15 will come in the numerator and 16 will go in the denominator, and I will get the value of n1 square as 15 divided by 16a5. Okay, so on taking under root on both sides, under root and under root here, the under root will cut down, and I will get a value of n1, my normalization constant, to be equal to under root 15 divided by 16a5. So this is how we find the normalization constant. So this is the normalization constant for question number 1, and now we'll move on towards the question number 2. Let's move on towards the second example. In the second example, I have to take the value of psi 2 equal to n2x a square minus x square. Okay, I have to take the value of psi equal to n2x a square minus x square, and I will have to plug in this value of psi in this equation and solve it further to find the value of the normalization constant n. So I will do this on the next page. Same equation of the normalization that says from minus a to positive a psi star dx is equal to 1. Now I have to place minus a plus a. Now I have to place in place of psi n2 square x a minus a square minus x square. Since the value of psi and psi star is same, so I am already taking the square. I am taking the direct square here. Dx is equal to 1. So the next thing that we are going to do is taking this n2 square common. So because the n2 square is a constant, so we will take it out here. So n2 square will get out of the integration and it will come here, and the next thing is the integration sign from minus a to plus a. The x square, it will come here, and I will apply the formula of a minus b as a whole square on this part of the equation. So if I take this as a, this is the minus, and x square as b, the formula will open just like this: a square to square a4, okay, plus 2a plus b square, a square plus b square. B square I have in the place of b is x square, so b square will come out to be x4, and minus 2ab. So the formula, I'm writing the formula here: a minus b whole square is equal to a square plus b square minus 2ab. Okay, so I am just following this formula here. This is a square, this is b square, and minus 2 into, in place of a I would write a square, and in place of b I would write as x squared, and bracket closing is equal to 1. That dx is here. So this is what will come out to with this what will come out when I will apply the formula here. The next thing that I'm going to do is just closing out the brackets. This will become x square into a4 x square, and x square into x4 x6 minus 2 into a square x square, and this x square will become x4 d of x equal to 1. So now I'm going to apply the integration here. So when I apply the integration, you will know what will happen. This x square will become x3 by 3. You know the rules of integration. This will become equal to a4. First of all, I will apply the integration. So this will become x3 divided by 3, and this will become x7 divided by 7, and this will become minus 2a squared x4, and so it will become x4 by 5, okay, is equal to 1. And limit was minus a to plus a, so here is the limit, minus a to plus a. So I have just applied the integration. You know the rules of integration, that if you apply integration on a x square, then it will comes out to be, if I apply integration on x square, then it would be equal to x2 plus 1 divided by 2 plus 1, so it will be equal to x3 by 3. So I have just applied the integration on here x square, on x6, and on x4. Because 2a is constant, I will not apply integration on this. Similarly, a4 is constant, the integration cannot be applied on this, so integration is applied on only x square, on x6, and on x4. So using this rule, I have applied the integration. So on applying the integration, the next thing that I am going to do is apply the limit conditions. Now if I apply the limit conditions, first of all, the upper limit condition, the upper limit condition is a here, so I will just put a in place of x, and here x. So let's just do this. N2 squared, giving out a4. In place of x3 I would write a3 divided by 3 plus, in place of x I would write a, so a7 divided by 7 minus 2 into a squared. In place of x I would again write a to power 5 divided by 5. Okay, so this is what will come when I put the upper limit. So now I'm going to put the lower limit. On putting the lower limit, you can find the equation will become similarly as minus the n2 square is as a whole common here. Okay, so on putting the lower condition, it will come out to be equal to a4. Okay, so this was a4. I will have to write the a4 here. So a4, and in place of x3 I would write minus a, so this will come out to be minus a raised to power 3 divided by 3 plus, in place of x I would write minus a, so minus a raised to power 7 divided by 7, and in place of x I would again write minus a, so this will come out to be minus 2 a square, and in place of x I am writing minus a raised to power 5 divided by 5, and this is the outer bracket. Okay, so that all equation is equal to 1. So now I'm going to multiply the a's with each other. So this will be equal to a4 multiply a3, a7 divided by 3, and the next thing is plus a7 divided by 7 and minus 2 into 8. This will become equal to be a7 divided by 5 minus minus a's cube will be given out as minus a, so this will come out to be minus a7 divided by 3, and this will also be equal to minus a7 divided by 7, and this will also be equal to minus minus plus 2a7 divided by 5, so is equal to 1. This is the bigger bracket here. So the next thing that I'm going to do is just apply this minus sign and find the final equation here. So if I apply this minus sign, this will come out to be just like this: a7 divided by 3 plus a7 divided by 7 minus 2a7 divided by 5 minus minus plus a7 divided by 3 minus minus plus a7 divided by 7 minus plus minus 2a7 divided by 5, and this will be equal to 1. So the next thing that I'm going to do is taking a7 is first of all adding these. On adding these, the equation will become just like this: a7 by 3 and other there is a7 by 3. This is a7 by 3, this is also a7 by 3. So this will come out to be a7 by 2 into a7 by 3, because there is one a7 by 3 and another a7 by 3. So on adding these two, this will become equal to 2 a7 by 3. Similarly, I have a 7 by 7 and a 7 by 7. So both on adding both of these, this will become equal to 2 a7 by 7. And the next thing I have is minus 2 a7 by 5 and minus 2 a7 by 5. This will come out to be equal to minus 4 a7 by 5 is equal to 1. So next thing I'm going to do is just taking a7 as common. Now if I take a7 as common, this will become equal to n2 square a7 2 by 3 plus 2 by 7 plus 4 by 5 is equal to 1. Now adding all of these by using simple LCM method, that answer will come out to be equal to 16 by 105. You know the LCM method, so similarly applying the LCM method and adding all of these, I will get an answer like just like this is equal to 1. So the next thing, I am going to find the value of n2 here. So 105 will go in the numerator and 116 will go in the denominator. So n2 square, and a7 will also go in the denominator since it is in the numerator here. So n2 square is equal to 105 divided by 16, and a7 will come here. Okay, so I've just rearranged the equation and taking under root on both sides. If I take under root on both sides, then n2 will come out to be equal to under root 105 divided by 16a raised to power 7. So this was the answer of n2. So our normalization constant is calculated. So that was our topic of normalization of wave function. See you inshallah in the next video.